G'day folks. It's another little afternoon in the shop. Not much else to do at the moment because it's freezing cold outside. But I figured we'll finish this coupling up and get that power unit together. As you can see, it's a little bit blue at the moment. Not entirely sold on the colour scheme, but it was better than the light grey that I was using because I was just constantly having bleed through from the old paint. No matter how much I sanded and washed it down with prep wash, just kept bleeding residue and colours and probably just oil residue through. So I ended up letting it tack off and just went over it with the same brand of blue, which is all epoxy. I don't know what it's like for temperature rating, but it's pretty damn good. You can paint over some pretty rough, nasty surfaces with this and it doesn't go too crazy. So with the coat of grey gone tacky in this stuff, you can see little blotches, but it's nowhere near as obvious. Like there was something underneath. It's a really hard surface to paint on. Trying to paint oily old machinery is just a nightmare. If you want perfect finish, you've got to strip it back 100% back to bare metal and go from there, but I don't need to. It's an industrial piece of equipment, so yes, it's blue. I'm thinking blue, black and green. Power coupling and the engine itself are going to be black and green, and the hydraulic side of it will be blue and black. So it should work out quite well. Might paint that black. The valve block and everything, yeah, I'll strip that down as much as I can and give that a good clean up and probably paint it black. Same with these lifting points or whatever they used to be, maybe old returns. I think they put them in as lifting points, but they are actually hydraulic fittings, so I can use them. I could just blank them off with something else, which I should have done before I put the lid on, because now I can't get to it. Damn it. Anyway, I might, once I get the Battenfeld vertical injection moulding machine, I'll be able to strip that down for bits and use whatever bits I want. I won't have to worry about pillaging those. They can stay there as lifting points, which I'll need. Definitely going to need lifting points on this. The other thing's going to be where to lift it from that end, so I'm thinking instead of some big washers I'm going to put some tags with eyelets in them. Similar to what the old variable frequency drives used to have on them. Not an eye bolt, but I've got some tags from a Danfoss drive somewhere that are slotted and have just a 12mm hole in them. So they'd bolt them to the back or the side of the cabinet and you just hook your chain, hook through it and lift away. Obviously for big drives, like the size of bar fridges and bigger, but yeah, rather than having eye bolts, because I'd have to, you can't really drill and tap into that anymore. It just makes more holes in the cavity anyway. I'd rather use the bolts on this flange to lift it, or just a strap around the underside of the bell housing there. Bit of lifting webbing. Either way, it's easy enough to move it around, and once it's all coupled together on a platform, I'll probably have risers with 4 eye bolt holes, and I'll just use a lifting jib that I made up. Well, that little load spreader. I just drill and tap a new hole and bolt a eye bolt through wherever I need to balance custom loads, that sort of thing. That one there's for lifting the Yanmar diesel, that one there's just in the centre for evenly balanced things. But the Yanmar wasn't very well balanced with the front half on it, or the old front pump mount. That's gone now, so I've got to make another lifting lug point. Anyway, let's look at assembling this. I'm going to clean the old pins up. I didn't get any new pins, but it was about $17 for a, or $19 of GST for a bag of replacement cone rings. They're a was it David Brown number 17 cone ring, and they fit over that shoulder there on tight over these pins, just like this sample here that I've had around for years. This is what I was going to get the whole pin assembly, but they didn't have any, and it's easier just to replace these washers. There's nothing wrong with these ones, it's just I trimmed the end off to get rid of all the burrs from where people had hit it with hammers or whatever. But there's still plenty of reach for that nylock nut to go on there. And the nylock's for $1.75 for 10 of them, so that's cheap enough. It's one thing I'm short on is 10mm nylock nuts. I've got about 500 stainless steel regular flare nuts, but that's about it. And as you can see, the old washer's not so happy. Well and truly worn out. That one's not so bad, but the outside's worn off it. They're actually supposed to fit, not snug, but just loosely in those holes there. Like, they won't stick, but they don't have much movement on them. So that's what we're doing tonight. And also got another wire wheel. Need them. So I've got to clean that mess up. Strip all these old washers off, just cut them off, and I'll let them fall off. And yeah, wire wheel everything clean, and away we go. And I've had a ton of people ask me what this is, and it's a little, just a cheapo engraving cutter grinder, but you put a worn out cup wheel on it, and you can use them for nice dressing jobs. It's an Alox wheel. You just don't want to grind on a cup wheel that's full size, because you breach the integrity of the outer cup and they can explode. I had one which I started to do that years ago until someone told me off, and I promptly broke it up and threw it in the bin. But yeah, nice machine. That was a gift from a former employer. We were having a huge clean out and found this thing under the bench with most of the tooling missing. I later found the collets and things, but yeah, I think they tried to sell it and gave up. It's not very practical for anything other than grinding cutters or that sort of thing. I have ground a couple of valves on it, but you can't really get the full angle on it. You got to do some really weird angle adjustments with this just to try and grind a valve. But it could probably be modified to swing past its normal 90-degree turn, and you'd be able to grind valves with it. Not bad. It's good for little jobs like this. As you can see, I use it a fair bit. Not bad. Come up alright. Now to do that 8 or 7 more times. Now I know guards are a bit of a no-no on wire wheels, but I've got my reasons. I know how to do it smartly. And don't ever tell me to wear gloves on something like this. That's the worst thing you can do. Gloves are much easier to get caught in this sort of thing and yank your hand in. Same with lathes and drilling machines, things like that. I've got rough hands because I know you just can't wear gloves on them without the risk of getting caught on the tiniest thing, and that glove pulls your hand in. Then it's goodbye wrist, arm, whatever. Goodbye life. So no gloves on rotating machinery. At least this sort of thing will give you a nasty burn and little graze, but it doesn't grab skin quite as easily as it does a tough leather glove. And of course, full face visor. I think I originally had this on because I was getting hit by wires. I just had glasses on, and yeah, when I put the big new wheel on, I'm going to take this off and just make one which is just sort of a third or a quarter guard, and it's just big enough to stop any wires that are coming up that direction from hitting me in the neck and the in the chest. Because you do notice them, you do end up occasionally pulling wires out of your wind sheeter. And the grinding machine itself's pretty old. It's an old it's like a 3/4 horsepower or half horsepower Betts electric motor. And Dad bought this brand new back in 82, 83. I've got a tapered spindle for a mop, polishing mops, that sort of thing. I've got a stitched rag mop as well as this one. They're very handy for that sort of thing. Likewise, 3M make a nice line of Scotch-Brite multi-layer Scotch-Brite wheels, and they are fantastic for cleaning stuff like this up after you've done the wire wheel prep work. Hit that on a Scotch-Brite and it takes a lot of sharp edges and excess other remaining rust and tarnishing off. But they're fairly expensive, so I don't buy them that often. It's a bit unnecessary for most things. Okay, there we go. Out of all the pins, there's only one that I'm rejecting, and that's that one there. It's been belted a few times with a hammer and has a rather unusually deep wear groove in it compared with the other ones, which are all almost pristine. So that one's rejected, and that one's still alright. And I'll just use this new old stock replacement. The rings on it are decades old, so I'm going to replace them. But yeah, this part was just, I think we threw it out at the foundry when we moved factory from Braeside to Seaford. Yeah, that's where I got these from. It was in a box of tooling. There were about half a dozen of them. It's the only one left. I don't know where the others went, but yeah, it was in a box of old lathe tools and bolts and T-nuts and other bits and pieces, old Imperial stuff that my supervisor was going to hoik into the steel bin. It's like, nope, I'll take that. And finally it came in handy along with some of the tiny little old lathe bits and things, so the industrial surplus is fantastic. I love it. Anyway, I'll give this a clean up. I'll just buff it back to what these ones look like. It's got a electroplated coating on it, but I'm thinking I'll just spray paint the heads of these once they're done. Easy job, easy done. And I'll use fresh new little V-rings, cone rings. They're too old. Keep them away. Almost ready. Just got some paint drying on the bolt heads. And since these are a perfect half-inch hole, I happen to have a half-inch reamer. And just do that, clean out any dirt and paint and other crap. So I've done that through the holes and ready to go in. There's an old one, for example. They're not as tight a fit as they were when they came out, simply because I've taken all the rust and stuff off that was holding them in there. But do the nuts up nice and tight. Might even put a bit of Loctite just around the hole there. Set them in there, do them up really tight. Not a problem, not going to go anywhere. Okay, there we go. It's going together pretty easy. Reaming the dirt and crap out of the holes makes a difference. That's one of the better fitting pins. Some of them are a little bit loose, like that one. But again, there's only a tiny amount of play in it, and I wouldn't... Even testing with the brand new old stock pin, still a little bit loose, and every single one of these was really tight when I took it apart, so they hadn't been flogging around and ruining themselves. It's just cleaning the rust off them has made them a little looser. Not a problem at all. One little drop of blue Loctite on the bearing surface and one on the threads just for extra measure. Perfect. I mean, I'm never going to be pulling this thing apart. Unless there's something horribly wrong now, as I put it together, I'm never going to pull it apart. It took decades to wear this thing out. It looks like it's already had a replacement set of pins in it anyway, because these pins are metric on the threads and everything. The head is 17mm and the thread is M10, and they got M10 nylocks on them. But it's just the inner land and the outer land on it, the shoulder I should say, is a ½ inch because it's designed to go into an Imperial coupling, which is essentially what this is, but they've just bored a tiny bit out of it to make it 35mm. So it's inch, or sorry, probably, what would that have been? It probably would have been 1 3/4 inches or something like that, something close. Can't quite remember what that is in metric. But either way, the grub screws are Imperial, the pinholes are Imperial, ½ inch. Yeah, it's an old coupling, it's had new pins on it, but in my lifetime I doubt I'll ever be changing these bushes, and if that's the case it'll be time for new pins anyway. Not that they're loose, they're actually pretty good. It was only that one worn pin that I rejected that they were loose on. I stuffed one over it and yeah, it's loose. I don't know why that one pin was reused. Maybe it was one of the originals. Don't know. Maybe they didn't order enough. Anyway, enough rambling. Let's finish this thing off. Oh, I just realised after painting you can actually see some legible markings on it. Looks like MC0427 David Brown. So it's also the same manufacturer as these rings. Perfect. It's actually a genuine coupling. It's not a cheap knockoff. I'm sure these are available on eBay for the same sort of price that I paid for these washers, but Still, this thing's been around for ages and it's going to be around for a lot longer. Look at that. Perfect. I think this was a PTO coupling on a tractor or something, 'cause it had a lot of rust and wear and tear and other muck all over it when I found it. It had been taken off something. I just found it in the scrap bin like that, just caked in mud and dirt and other crap. It had been sitting in someone's garage for the last 20 years. So yeah, it's a genuine part, genuine coupling, genuine replacement or whatever, cone washers, cone rings. Perfect. I've got a few extras just to be safe. You can use them for other things anyway. Rubber washers never go astray in a workshop. Those ones can go astray, they can go straight in the bin. They are shot, and most of them are cut through with a razor. You do have to cut them, some of these are just so hard. So that's all rubbish. That's for the secondary drive coupling, and that's the primary. Next step is to fabricate a adapter plate for the engine flywheel, and that's going to involve drilling and tapping 4 new holes in it. A very minimum of 4 new holes. So that's going to be interesting. I'm going to work out what to do with that one. Maybe a extra drive plate, an external drive plate made out of the old Daewoo flywheel perhaps. Not too sure. Anyway, we'll work it out. The flywheel on the Yanmar is a nice thick stocky one, so there's no harm in drilling and tapping a few 10mm holes in it. It's just a matter of making sure that everything's concentric, and I machine a spigot on the hub so that it centres on the centre spigot of the flywheel, and the holes just make sure they're balanced out. Even dial it up on the mill at work and put the DRO into PCD mode, 5 by whatever PCD, probably the same sort of PCD as this, like 110, 120mm between centres. Easy. Modern electronics make things really easy. So there you go, that's a finished coupling. Thanks for watching, and stay tuned for more.